Great, thank you. Okay, thanks, Ryan. Let me go ahead and get my presentation up here. Yeah. Okay. Anybody else have this problem with Zoom getting in the way of everything? And now I can't find the buttons that enlarge the. Just want to go to full screen.
It's like every video starts with fiddling around with Zoom.
Fiddling around with Zoom, exactly. Sorry about that. Is this good enough for people in the room? I think.
Yeah.
Okay, I'm trying to get it to full screen, but it's the Command F is not. So, okay, so basically, I want to share with you guys some research that I've been working on. And it's like a series of papers that I'm writing. I have this data set, which I'll describe in a minute, which is hand-coded conflict events. And so I'm trying to see to what extent we can use low-cost, open source models to replicate, the codings of human coders, basically student coders. So this particular paper focuses on using sequence-to-sequence models to extract event counts and location, um, like where a conflict event occurred, how many people were injured, how many people died, and other papers focus on other aspects of the coding, like what kind of event occurred, or like was it a bombing, or was it a shooting, or what kind of organization was involved, that kind of thing. Um, so I've been working on this research with Mohideen Batshashekh, who was a student in the data science program. He's now graduated, is working in industry, but he's helped a lot. And actually, this idea to use the sequence to sequence models for these tasks was his. So wanted to try it out, and see what we came up with, see how good it was. So this data set that I'm working with is 10,000 hand-coded events from a database called the South Asia Terrorism Portal. And what we're focusing on specifically is the Maoist insurgency in India, which is actually still ongoing at a low level, but it's an insurgency that's been occurring since the 1950s, if you read the history in one form or another, in India, but there was a big resurgence of violence in during this period, especially from like 2005 to 2010. And so I've been working on this, studying this conflict for a while, and I had a team of coders working on, like I said, extracting information from the textual descriptions. Um, One of the nice things about this data set is it's actually human um, summaries. So it's summaries of conflict events. So they have a person that they employ, this NGO that does this, nonprofit that does this work. They have somebody sitting in a conference room like this, reading newspapers, and then writing a paragraph or two-paragraph summary of the event, like the key characteristics of the event, and then they post it online. Okay. Um, so the reason this is interesting from a social science standpoint, I think, is because this data set is characteristic of bespoke data sets with like niche labels, and lexical complexity that we find in regional and conflict studies. And I'll show you an example of that, like an excerpt of like one description that sort of shows what I mean by lexical complexity and niche labels. And the question is, how much can we autocode these events with low cost and open source models as opposed to using, more expensive methods? And there's a lot of research going on in social sciences now because nobody wants to fund these. We need these data sets. We need conflict data sets. We need event data sets to do, uh, analysis of protest events and conflict events, but it's very expensive to hand code them, obviously, because you have to employ a lot of people. So this is one example of a description you might find in a data set. The Nalgonda District Police killed four CPI Maoist cadres in an encounter on the outskirts of yeah, I'm going to get it wrong, but Yelamanagudam village in Gurampuru Mandal, which is a block, an administrative division called a block in English. Unconfirmed sources said that a senior second rung leader, Bettaraju Narasimhan, alias Muku Ravi, alias Janardhan, was among those killed. Superintendent of Police Vijay Kumar said that 2 to 4 Maoists might have managed to escape. So there's a lot going on here in terms of place names. And a model, AI, would have to be able to distinguish between, place names and, names of people. If we look at, the count here, 2 to 4 Maoists, so that's kind of complicated. What do you do with that? So we might have had a rule for the coders saying, oh, that's going to be 3. Just take, the median or something. But what does an AI or what does an LLM do with that, or a decoder model or an encoder model, or sequence model? What are they going to do with this lexical complexity? So just to kind of give you more of a more details in terms of how we coded this data set up, like with humans. So we actually had quite a rigorous set of procedures in place. We had a hierarchy on the team. We had a graduate student supervisor supervising 4 to 6 undergrads who were coding with each other in pairs. So they would each code an event and then they would compare their codings. And if there was a discrepancy, they would try to resolve it. And then if they couldn't resolve it, they would approach the grad student supervisor. If it's something super confusing, then we would have a weekly meeting where we discussed the most confusing cases. We had a structured onboarding process where we would train them how to read this text and key terms that they might not be used to seeing, like some of those you just saw in that description. Supervised trials, all events, like I mentioned, were double coded. We had regular meetings, like I mentioned, and then process of resolving discrepancies. So the question is, could you quote unquote hire bots instead to do this work, and how effective would they be at it? And so this is a larger research project that I'm doing. Like I said, there's multiple parts. I have one for basic classification tasks. Then I have this paper on location and counts. Um, so what we found is like simple classification tasks tend to be pretty straightforward. Like, did a Maoist organization or insurgent organization or the police engage in the action, the attack, right? Who initiated the attack? A simple decoder like a BERT-based model is pretty good at doing that. Multi-class classification also not too bad. So add another category, could be the police, could be the insurgent organization, could be other, right? And it'll do fine with that. Multi-label classification, which of these weapons was used. Also tends to be pretty good at that. It was a little bit harder. F1 scores are not quite as great. But then we get to place names and counts. Traditionally we've used classical named entity recognition, like dictionary-based methods for this, which tend to be pretty inaccurate. Spacey, Gleiner's a newer approach, which is not classical NER, but it's been around a while now. Count models are challenging because they're not named entity recognition, not a person, place, or thing, but it's not a classification task either. Maybe you could approach it like that. Did this place appear or not? But then you would be, I don't know how many times you have to run the model through to make that work. So counts are tricky. And it's hard to say what to do with place names and counts in the world of, transformer models or LLMs, right? How do we approach that? And then one other thing we found is imbalanced data. Naturally, that's more challenging. So if you don't have a lot of cases to train a model on, or to look at, then it becomes challenging. So there are some situations, where we're still going to need a human in the loop to deal with some of the stuff that's not as frequently seen. Um, so why sequence-to-sequence models? So I think most people are probably familiar with in this realm, right? In our world, familiar with the difference between decoder and encoder models. Encoder only models are like the things that we use every day for, basic questions and generative AI, right? Modern LLMs like ChatGPT and Claude, they're good at generating text. Decoders tend to be good at understanding contexts and extracting text, classification tasks. Um, so question here is, could encoder decoder models be good at these specific tasks of counts and of place names? Um, and there are a few reasons to think that they would be good at it. First, they can read context and generate text. So maybe you get the best of both worlds from encoders and decoders. But then also they tend to be good at dealing with situations where the output text is much shorter than the input, right? Or structured differently. So say, for example, you want your place name structured as state, district, village, right? And you want it in that order. Encoder decoder models tend to be, are used for that kind of task. They're used for translation tasks. They're good at, you know, structured output. So I'll talk first about the models that we used for trying to extract death counts from these conflict events and descriptions, and then I'll talk about the locations. In our analysis, we looked at sequence-to-sequence models. Mostly we were looking at T5 models or variants of T5. Then we also compared them against, LLMs, open source LLMs. And then our baseline model was a conflict BERT. It's a BERT-based model, which is trained on conflict-specific text generated, developed by a group of political science at University of Dallas, Texas, UT, UT Dallas. And and uh, and I found it to be very good, actually, outperforming like the base BERT model and other BERT models on conflict-specific tasks. So we use that with a Poisson head to try to predict, the counts, right, from the texts. Um, for the sequence-to-sequence models, we look at FLAN T5, which is Google's version of the T5. It's a little better than the base T5. So we look at the base large and extra large versions of FLAN T5. And then we look at some more specialized T5 models. MT5 is multilingual T5. NT5 is trained specifically on to extract numbers. So I could only find the small version of that. I don't know if there is a medium size or large version, but I only found the small. So it's kind of hard to get it to run at first, but my friend Claude helped me out quite a bit. So. Then Indic BART, which is trained specifically on Indian language texts. And like you saw from that description, there's a lot of Indian language terms. So we were curious to see if that would have any performance advantage. All right. So then in terms of open source models, we look at Llama 3 8B, Mixtral 8X7B, and Mistral 7B. And if you'd asked me 2 weeks ago, I would have been able to tell you how many parameters each of these have. But the main point is they're open source. It's maybe some of the details. Main source, there's some of the most, main point is some of the most commonly used open source LLMs that I could run on GPU on Colab. So. And then we have, proprietary ones, ChatGPT 4.0 Mini and Gemini Flash 2.5. And the main point here was to see, like, okay, do these outperform, because they have so many more parameters and, they're proprietary. And a lot of people are curious about that. So if I just present something and say, oh, I don't know if you have the experience. Oh, we're going to test all open source stuff because we like open source. People always say, well, how well does it do against the proprietary models? So these are prompts that we used, very simple prompts. For sequence models, we used how many people were killed, answer with only a number. For LLMs, we wanted to prevent the LLMs from elaborating. So we said we elaborate a little more to get them to not elaborate. So we said how many people were killed, answer with only a number, return JSON exactly as fatalities. If no fatalities are mentioned, use zero. Okay. So
Feel the LLMs getting angry at being limited.
yeah, they're frustrated. What a bust out. So then we did for the train test split, we did a 60-20-20 split. First, we filtered for violent events. So a lot of, as with a lot of conflict and event analysis, there's a lot of zeros because there are a lot of events, even in this database, which is a conflict event database. There are a lot of events that are described that have something to do with the mouse, something related to conflict that don't have any death counts, right? Or aren't really violent events, like 10 Maoists surrendered to the police. And that was a big thing for a long time. A lot of Maoists, former Maoists are surrendering. They're getting sweet deals to be rehabilitated and not having to go to jail. So they were all surrendering for a while. Um, and or there's some sort of seizure of assets or something like that. Doesn't involve like gunfire or anything like that. So we filtered for violent events, and then we did a simple 60-20-20 split where we weighted split based on the count bins, like no events, one event, two events, 3 to 5, and 6+. We were looking for metrics. We were looking at mean absolute error, root mean squared error, within one of the actual count, and then a count of within two of the actual count, and then the non-zero mean absolute error, meaning like just looking at the events where there was a count. So again, in case the models are not performing well based on the zeros. So this is the mean absolute error. This is the confidence intervals are based on a bootstrap of the 5,000 bootstrap samples, the test set. The predictions based on the test set. So then we can see that the flan T5. So we have in the black all events, and then in the red non-zero events. And we can see that the models are all doing pretty well on both, the full data set and non-zero. And in fact, for non-zero, we're seeing a slight increase in the MAE. The Flan T5 models perform the best among the open source sequence to sequence models. Um, and what else did I want to say? The larger the model, the better. But you know, Flan T5 large, which took a substantially less time to run than extra large and was a lot easier to run on Colab. Actually, I didn't have to make any like adjustments there to the code or like do anything special to run it on Colab, and that performs pretty well, pretty close to the extra large. So the performance gains on the extra large are not like astronomical. And then we see for the open source LLMs, um, the Llama 3 8B is doing as well as GPT-4o Mini, but both are doing pretty well. And most of the open source LLMs do, except for Gemini Flash. I was actually having problems with the Gemini models when I was running them because they were the request was being blocked, and the code that I was getting back was a 2, which when I looked it up was violence, some sort of a filter for violence, like a safety mechanism. So I don't know if that's what was going on with these results, but I wasn't having a lot of luck with the Gemini model.
You can turn that off in a parameters setting with the Gemini model.
Oh, you
I
can.
had to do that before.
Okay.
If it thinks language, yeah, you can turn on off. I think they have 8 different filters, like language, sexual connotations, and stuff like that. So you may have to turn that filter off.
Okay.
There's code out there for it. It's pretty
All
easy
right.
to find.
Okay. I'll check that out. Thanks. Okay. And so this is a comparison of all the metrics, not just MAE. And again, bootstrapping 5,000 reps and comparing with the baseline model. So the idea here is, is there a difference between, each of these metrics and that of the baseline model? And here we see, again, the FLAN T5 large and extra large doing the best. And here, when we look at GPT-4o Mini, when we look at the LLMs, the GPT-4o Mini across all of the metrics seems to be doing the best in terms of differentiating itself from the Conflibert baseline. And then one last thing to look at is the performance across the bins. So here we can see the real advantage of the FLAN T5 extra large. The performance advantage is on that highest bin of 6+ events. It tends to have a much lower MAE, mean absolute error, when we're looking just at that, and that makes sense because those are, the high event counts are more rare. Than most of these events, actually, if you look at the distribution, most of them are like 1 death or 2 deaths or something like that. So there are fewer examples, so it's learning faster because it's a larger model. Okay, now the location extraction tasks. Similar set of models here, except that we do one thing that's a little bit different, which is, so first I'll just talk about the sequence to sequence. So again, the three FLAN T5 models that we looked at before, MT5, which we talked about before. And so very similar set of models for sequence to sequence. I thought I changed out, instead of NT5, I didn't use NT5 for this. This is incorrect. I used a different one. Let me just race ahead here. FLAN T5, FLAN T5, FLAN T5. Indic BART and NT5 base. So I didn't use NT5. That's a numeric specific model. So this slide is wrong, but so the T5 models, and then the LLMs, same set of LLMs, did not use Gemini Flash because I couldn't get it to work at all on this task. And then the baseline is a Gliner. And one thing we did a little bit different here was we wanted to try a span-based named entity recognition, which is where you have a decoder model predict a span where based on the human annotations, predict the span on where the event occurred, and then extract the location from that span. So we had read that this was pretty good method and would be competitive. So we wanted to try it out and compare it with the T5 models. So for our decoders for the span NER, we used XLM Roberta, Deberta V3, and then Conflibert Mural, which is an Indian language specific decoder, and then SpanBERT, which is specifically built for span NER. Okay. Prompts. So for the sequence model, we use this prompt: extract location hierarchy from the incident. And then we told it to give this format back: state, district, village, and then other locations that might have been listed in the description. Use exact format with labels, omit missing levels. For LLMs, we said extract the location hierarchy from this incident, return it exactly in format: state, district, village, other locations. Use the exact format with labels, omit any missing administrative levels. Do not repeat the incident text. Output only the structured fields. If no locations are mentioned, return an empty string. Probably should have added, for good measure, do not say anything else. So for the train test split here, we were worried about like temporal drift because the conflict sort of moves around like India over time. So we're like, okay, we're going to do a temporal split because things might change over time. So we did an 80-10-10 temporal split. And we also thought that this would model real world deployment, where we're trying to predict the location names of, today rather than like, at 2005 or something like that. So again, similar set of metrics, but this time we're looking at F1 scores for per level for state, district, um, village, and other locations, and then a micro exact F1 across all the levels. How well did it do predicting all the levels together? An exact match for the core areas because the other areas tend to be tricky, right? If it's not a state district village, these other areas like such and such forest or some other name for administrative area that's not the official name, those can be tricky. So we wanted to see, okay, just with the core areas of state district village, how well did it do? An exact match of all places, which is a really hard challenge. And then I'm not showing you the fuzzy match results, or am I showing you only the fuzzy match results? But basically, what we found was like if we use fuzzy matches, like to account for spelling differences of the different like administrative um, places, place names, we get about 2 points higher when we do fuzzy matching instead of just strict matching. Okay, and good news is the sequence to sequence and the bootstrap models all do pretty well, and they tend to perform, you know, uh, pretty high levels and similar levels with each other between like 70 and 80% exact core match for those three administrative levels, state, district, and village. The span NER does about as well. So that's an alternate method that also performs well. And then, but the LLMs don't do as well. And, if you have any thoughts on why, something to do with the prompt that we're using, maybe you should put at the end, do not say anything else, that would make it better. GPT-4o Mini does better than the others, but only 60% exact core match. Which I think is surprising. But champions of open source, might be happy to see. Happy to see these results. But think one other thing, people were saying at a conference where I presented this was, these, uh, you know, um, uh, you know, uh, modern LLMs aren't really built for this kind of task. They're built for generating text, not necessarily for understanding context and extracting text. So maybe the older models are just better at this.
That's what I was thinking, because like entity extraction is very different from what LLMs are doing.
Right.
It doesn't know that it's a location. It just is doing next probability letter, right?
Yeah.
So I would, I wouldn't know that I
Yeah.
would expect it to be good.
Yeah. Cool. Yeah. So basically, so then comparing these models with the baseline Gliner model, which didn't do that well at all, actually, they all perform better than baseline. So actually, the baseline wasn't that hard to test in this instance. Same thing with the with the span NER with the BERT models. Even the LLMs do better than the baseline. So I don't know. I think I need a better baseline for this, but yeah, that's what we found with the location tasks. And then if we look across administrative levels, you know, even though it's interesting that even though the state names, the districts almost always mention the state is kind of inferred from the district. But even given that, these models are able to figure out which state it occurred in most of the time. So that's one interesting thing. In terms of the villages, that's a bit more of a challenge, but still, 75%, 77% of, getting extracting the village names, I think that's actually pretty good. And then other areas, like I said, are
this. Like just for thumbnail, looking back.
yeah,
There we're not 100%, I'm sure too.
yeah, they're not yeah, I actually haven't done that comparison yet. That is yeah, but I think if I were to guess, I would say that the undergrads were not always that good at that. We had to go back through and do a lot of cleaning of their coding. So, but it's obvious when it's a district. Sometimes it's obvious when it's a village because it'll say something something village, but district always says something, it says the name of the district and district. So it's clear it's a district, but
I also wonder if there's a way to improve it since all of those things are already known as real. Like if you just handed the full comprehensive list of here's every district and state pair. So you already know if you found this district or if you found this village, it's in this district, which is in this state. Like there's a hierarchy to the data. So you could pre-give the models, this is the only possible set. There's only 10,000 possible combinations, that you could extract. And so now go. And so it's really doing its best guess of which one of these is in this list or something. And then it would maybe fix it, like this is not minor differences in spelling and stuff. It would still be like, oh, it's close enough. I'll go with that one.
yeah. So like
Yeah.
I think a dictionary, I was trying to see how well it would do at the different levels without like using a dictionary, in part because there's like 750,000 Indian villages
So it's not.
and then you got to fold them, you got to figure, and then a lot of them have the same names, so
Sequence of like.
Springfield.
yeah, exactly.
No, so on, like that sequence is there are probably fewer multiples.
Yeah, but then you got to put that together or find that and then maintain it, maybe. So a dictionary-based approach is always going to be more work. I agree, though. It would, if you could get it right, it's definitely going to improve the performance at the village level. I think that's right.
Like the lowest bar. It's setting up. You could always do better.
Yeah.
If there isn't already an existing location database, then there's like no way to ever get 100%.
Yeah.
Even with humans, because humans aren't going to know what are they going to refer to if there isn't like and in a newspaper article, they could be talking about one place, but then it's got the same place name. What human would know, even from context?
Yes, I think this is an issue. Yeah. So the last part of this was, so that's the fuzzy, this is more of the same. But then we tried to geocode these, okay? And what we did was we took the locations from the best model, which is the FLAN T5 large, and we fed it to the Google geocoding API. Okay, and then had it return latitude and longitude coordinates, and then compared. We had we compared our gold standard. Gold standard was we hired a different team of students in India to go through our the data set, and where the village was mentioned, give us latitude and longitude for the village. And so we compared the Google geocoding to the human geocoding. And I guess one question is like, should the human geocoding actually be the gold standard, or should the Google geocoding API be the gold standard? But this is what we tried. So we tried a couple of different methods. We tried like constraining the state and district plus village, and then added village and other locations. So you have this option with the geocoding API where you can just feed it the location names that you have and see what it comes up with. Or you can constrain it to say, this is the state, that kind of goes to JP's point earlier. This is the state, this is the district, and here are the other location names we have. Figure out where it is, right? So we tried constraining state and district and then village and any location names. Then we tried constraining with state and district plus just the village. And then we just gave it a common delimited list of all the location with no constraints. And we said, okay, which of these is going to turn out best? And you would have thought that the constrained ones would come out better. Yeah. But actually we found that the comma delimited did the best. Yeah, by far. Yeah, but still not that close, like 14.5 kilometers median. I mean, there were some big outliers here. I have to go back and actually, I I have not had a chance to go back and sift through where the big misses were. But you know, sometimes it's putting a village on the opposite end of the country where the human coder did. And is that the human coder or is that some issue with that village name? I don't know. I have to go back and look. So that's basically what we came up with. Yeah.
So now the question, in the spring, we show us your code from running the T5.
Yeah, sure.
We've seen a lot of LLM stuff, but we haven't seen much with the sequence to sequence.
Yeah.
Like to see how you actually run the Flan T5. Like your notebook would be cool to see, I think.
Yeah.
I have lots of ideas for how it could be useful, but I'd like to get a preview of what I'm getting myself
Okay.
into
Yeah.
before I take on this
Sure.
other tasks.
Yeah.
I was right at the beginning, I was thinking of something completely different and totally contrary to what you're trying to accomplish. But as I was thinking about the problem, like you've got a piece of sort of arbitrary natural language, and from that you want to get some key information. You probably already have a vocabulary of stuff that you want to pull out. I don't mean like specific place names, but like I need a place name, I need the supplemental detail about the place name and so on. And I mean, this is a problem all over, like people who are doing media, like making films, they have to like put all kinds of metadata. They've got like henchmen interns that are just sitting there watching videos and like putting metadata so that then the director can, or the editor can like do a quick search and find the clips they need. And it seems like a similar problem. It'd be great if you just had a predefined set of tags, and then a reader can just like, a human reader can just like, oh, this is a place name, highlight place name tag text, you know, read through it, basically apply all the tags, take the text, and then from that you could sort of do your statistics.
Yeah.
And you could also put in very explicitly in that, like, location uncertain from this text, like it's, you know, like the source data doesn't really, you know, specify, is it this village or is it this other village that has the same name?
Yeah.
Like where there's ambiguity, it can at least be explicit about that, so you know you're dealing with something fuzzy.
Yeah. Yeah.
And that's like manual labor, but it constrains, you know, as a task, it constrains it in a way that
I'm curious to know if in the film industry, if that some of that human labor would be replaced by LLMs, or like a basic liner model can identify place names, for example.
possibly from like, the one thing I can imagine doing right now just with Adobe Premiere is like, okay, do a transcription of all audio. So at least you could say, when so-and-so says this, show me all the clips.
Right. Yeah.
What I'm seeing on sort of job listings, there have been a lot of listings lately for people to watch videos and write descriptions of them, like put in, you know, keywords and stuff to train models. So right now it's still at the sort of, I would consider this still Mechanical Turk, like that part of the model building is like, yeah, you still just need like thousands of people like banging away. And one of that listings I saw was interesting because it was like, yeah, we need people with actual like film or visual arts backgrounds to give us much more like nuanced descriptions, because the stuff they've got right now is, you know, it's pretty vague. They like to be able to talk about the tone of a video clip or pace or something. Like there's things about editing that you can't, it's not necessarily a one word answer, but it's there are things that filmmakers and film editors would know, like, oh, I need something that's more frenetic, or
Okay. So it's not like just something simple that like a positive or negative tone or something like that. It would be.
And a lot of that is, how much of that is interpretation of the viewer, because that's the whole point of art. It's like you're
right.
You know, for stuff that's not art, like industrial videos, yeah, you don't need to worry about that. But I'm always on the edge cases of like, what about the unknown stuff?
That's super interesting.
Yeah.
And the people who are doing the coding, are they unionized?
When you say coding, you mean like
The writing the metadata.
Yeah. I don't know. I don't know where that, I mean, I'm just seeing ads on LinkedIn for like they're targeting me personally, James. $100 an hour contract.
You can see why they want it though. Like from an editor perspective, if you have you have to get it down to 90 minutes and you have
Um,
all these minutes that you have to edit, being able to know what you have. And like when I used to edit my podcast, we would
Right.
have like an hour and a half of content and I had to get it down to 30 minutes.
Right.
So I was always trying to figure out like, oh, I remember somewhere like around minute 120, something was said and it was about the right length and that had the right. And so that jumping around, if you had metadata, would make the editor's job much faster.
So transcription, audio transcription helps with that. The problem with like a film shoot is you'll do 20 takes of a single shot and there may be 60 shots in a single scene. So like, okay, editor needs to find, there was one really good take, with actor A and one really good take with actor B, and I need to find the two takes so I can edit those, kind of, mush those together. And so when you think about a feature-length film, the number of not just shots in the movie, but all the takes that led up to those shots, plus the stuff that, hits the cutting room floor.
Yeah.
There's like a lot of material that they have to like sift through and
Wow.
navigate.
It's amazing what they do. If you want to watch something cool off topic, we're watching Adolescence. It's on Netflix.
Yeah.
The topic isn't something I would normally watch, but it's shot as in one take as a continuous take. So like the camera just starts with a person and then you jump, like flow to the next person and flow to the next.
Right.
Amazing cinematography work of how
Is that all in a single shot?
it's all in a single shot, but with multiple cameras. So yeah, there's
Right.
actors only get one shot at it.
Right.
And they start at the beginning, the first actor starts talking, they walk to the next room, the second actor picks up, they walk out, they go. It's just really, from a filmmaking perspective, it was fascinating to watch.
There's a couple of movies like that. Rope by Hitchcock is almost entirely one take, one camera, one take. I think there's one cut in it, like 3/4 of the way through. And then there's another movie called Russia Art, which is super interesting. I can't even describe it. It's the location is a museum and it's just a single continuous shot for 2 hours or whatever it is. It's amazing.
When they do different takes, are they looking to just experiment with different things, or is it like you got it right or you didn't get it right? When they do another take, does the actor feel like, or the actors feel like, oh my God, we have to do that, we failed, or
All of the above.
Mhm.
Sometimes it's just like if it's at the time, because it's time is money, film footage is super money, crew is money. It's so like you're trying to. You don't usually have the luxury of trying out a whole lot of stuff unless you're like Charlie Chaplin, who would just shoot 100 takes of something until he felt it was exactly the performance he wanted to give. And he was in a position where he was director, producer, actor. Nowadays, like if there's time and budget and that